Next speaker is myself. I'm the chairman of Sea6 Energy. This is a startup out of IIT Madras. So I will be talking to you on macroalgae and the potential for macroalgae cultivation. Okay. So let me come here. So the next slide, please. So I have a few general slides which will be used to set a little background. And the most important thing is that the GDP of a country, and in this graph on the bottom horizontal axis you have the GDP per capita, and on the y-axis you have the energy consumption per capita. So if India is growing at 8%, basically what this graph says is that your energy consumption has to increase very, very substantially. Because, you know, when you interpret GDP as a standard of living, we can see that when we want a higher standard of living, you're talking about taking a flight here or driving a motor car or having very nice highways, all of which are energy intensive. And you can see that right now, India is almost at the bottom of the heap, but we are already the third largest consumer of fuel in the world. Okay? So the next slide, please. And this is very clearly reflected. If the black line up there shows you the rate at which our consumption is increasing, the gray bars are showing you that our production is more or less static, and the red curve shows you how rapidly our imports are increasing. And we're dependent upon imports. So there's nothing wrong with importing oil if you have the money to pay for it, except that nowadays, even if you had fossil fuels, like we're very coal rich, right? You can't afford to burn them without your neighbor complaining, without putting the carbon dioxide out in the atmosphere. And that's the difference between China's growth and us, because they started burning a lot of coal 20 years ago before global warming even became an issue. But even if we have the coal, which we do, we can't afford to burn it. Therefore, renewables are really the only way to go. Next slide, please. So just to give you a snapshot, we talk about fuel, but this is a snapshot of last year's oil consumption, and we import roughly 157 million tons. All these statistics are taken from the Government of India Ministry of Petroleum, and out of which what we see in our daily lives, which is petrol for instance, is only 9% of our total oil consumption. Diesel is about 4 to 5 times more than petrol, and all of that is about half of our total energy consumption. So it's important to remember that we consume nearly 157 million tons, out of which a lot of our biofuel replacement basically thinks about, it's making a we're targeting a small area. Next slide, please. So if you talk about renewables, the first thing we have to realize is really the only true renewable we have is sunlight. Whatever you look at, whether you look at wind, is a form of sunlight. Because that's what happens, when the sun heats up one area and cools down another area, that's when the wind blows. Okay? Whether you talk about hydroelectric, it's also a form of sunlight, because without the sun, there would be no rain. Without the rain, there would be no water collecting in the rivers. So it's all a form of sunlight. And fortunately for us, if 15 terawatts is the current global consumption, and sunlight is 86,000 terawatts, so even so, there is, in theory, plenty of sunlight to satisfy all of mankind's needs. So, next slide, please. So what does mankind use today as energy? Basically in two forms, either as electricity or as chemical energy. And when I say chemical energy, you mean the LPG you burn in your fuels, or the petrol you put into your cars, or the coal that we burn in our thermal power plants, and that too to produce electricity. But we use only energy in two forms. Both forms can be produced by sunlight. And a lot of you have been looking at solar cells and wind and all of that, and that does produce a lot of electricity. But there is always an irreplaceable need for liquid fuels that even if someone projects that, electricity is going to solve all our problems, it is not. And it arises out of the fact, if you look that, you can hardly see this graph, but you see, this is an energy density storage graph, which tells you how much energy something packs per liter. And if you take your car to the petrol station, and you say, I want to fill it up with 40 liters of petrol, you expect that your car will go at least 400 kilometers, even if assuming it's an old model car. But if you had a 40-liter battery, you would not go more than 80 kilometers. I guarantee you that. Because the energy density of a lithium-ion battery, which we still don't use in our cars, is somewhere there. And this is the energy density of diesel and petrol. It's way up there. So very few things can replace the energy density of fuel. And that's